I'm going to be recording the session. Okay.
Okay, so now I have to behave.
Yes. Right.
Okay, time to go on mute.
And thank you for joining us again on this beautiful Friday afternoon. We appreciate you showing up and sharing your time with us. This afternoon, Kurt has put together an excellent training piece on ADAS calibrations. So the meeting, of course, will be recorded and available to you afterwards. And if you have any questions, please put them in the chat and we'll be monitoring the chat. And periodically, Kurt will stop and we'll have a chance to have those questions asked and answered. Great. Kurt, take it away.
Cool. It's good to see everybody again. You know, it's been a while. I had to remember how to do this. So it was a little strange. Since I can see some of the faces, Mike, I'm going to use you because your face is still there. You can see the shared screen, says ADAS calibration and everything. And can you hear okay? Cool. So, you know, we went through the systems and some of the components and operation and things like that during the summer. And, you know, it was nice to hear a lot of people have been using it both throughout California, college level, high school level. Some of the other Western states have found out about it and it's trickled into them as well. So I'm glad everybody's able to get use out of it, whether they send them watch the video or they make them pull things down or whatever. Everybody's getting something out of it. And this is basically that next step. Our original goal was to do hands-on. And, you know, COVID kind of got in the way with all of that. So what we decided to do is pull this together as kind of a first step or a prerequisite or whatever you want to call it between what we did with the systems and the light discussion about calibration. And then the next step being, hey, hands-on doing this stuff. And we're hoping that as things keep going in the positive direction, maybe we'll be able to do something this fall and get people into the schools and do it. I know quite a few of the colleges have bought equipment and maybe it's still sitting on the 4 pallets that are, you know, huge if you've bought the Autel stuff. But little by little, I think more and more of us are going to see it, going to have it, and going to be touching it more as we go. Some things to keep in mind. Remember, this stuff is changing all of the time. When we talked over the summer, you still saw a lot of vehicles that were, you know, they were very adamant in the manufacturer information. If you did this, you had to do calibration, especially like with alignments. And you're starting to see some of that back off a little bit. Some of the manufacturers have kind of pulled back on saying, hey, if you do this, you have to do that. The problem is they don't give it any parameters still. So if your alignment's out of tolerance by X amount, is it still okay? Do I have to do the calibration? Do I not have to do the calibration? You know, what is those tolerances? And they're still not documented anywhere. You know, to some extent, you could roll the dice and take a chance, but liability comes into play, or you play safe and you do it anyways. And for me at this point, I think with all this, that would be my recommendation. Play safe, do the calibrations anyways, but we're going to talk more about that. At this time, there is no industry recognized certification for ADAS calibration. So you can't go take an ASE test on it. There's no state test for it, nothing. It doesn't exist outside of the manufacturer factory training classes. So that runs some challenges. So there's a lot of discussion happening, especially in ICAR, the collision side, for coming up with some formalized training, testing, et cetera. There's been a few different groups talking with the state of having something along the lines of a brake and lamp, having included in that realm in some way, shape, or form, but who knows how far off that is. And ASE, yeah, maybe someday, eventually, hopefully. So there's going to be a lot going on with this stuff. The good thing is the foundations are really applicable across the board. So whether it's an automotive application or a collision person or even a heavy duty truck, because a lot of truck has ADAS already, and they're growing as fast as the automotive side. And in some ways, their movements towards autonomous and stuff is probably going to even happen faster than it will with passenger cars. So they have a lot of incentives. And then off-road vehicles, farm equipment, things like that. So there's a lot happening. It has a broad application for what we pick up in these classes. And then finally, you've got shops, more and more shops that are opening up specializing in ADAS calibration. And they're actually doing sublet work for dealerships in some cases, because the dealerships may not have the space or the equipment or the time to do it. So there's a lot going on with ADAS. Let's see if we can get things clicking here the right way. So some quick housekeeping. Thanks for taking the time. I know we're all crazy busy. Make sure you got your name and your school association in the chat. That way Pam can get all the certificates for you guys. Whenever possible, keep the mic off, only because the sounds in the background are really cool and listening to, except for when people go to the restroom and things like that. Those sounds, you just never leave your brain. Post questions to the chat whenever possible. And that way I'll stop like I did before and read right out of the chat. And if there's something in there that I just can't make sense of, I may say, hey, go ahead and fire your mic up and clarify it. It just makes it faster for us. I may or may not be able to see you. I've got about 4 windows open on my desktop right now, trying to see faces and chat and participants and all that kind of stuff. So I may not see you waving. I may not see the little hand pop up or anything like that. Don't take it personal. I'm not ignoring you. I flat out might not see you. So make sure it gets in the chat, and that way I'll get to you as quick as I can. You might have to reshape your window a little bit, because I do still use it as a widescreen so that you can see more on the slide versus the traditional little more square-ish screen. And if you have any questions, feel free, send me an email.
Just want to add one thing real quick, because this came up in several emails. There will be no compensation for the training. I know that this came up for several of you. We are now thinking how we're going to be compensating for training going forward, whether or not that'll be something that the colleges then use their local SWP money for. There were a lot of issues around trying to get everyone paid when I had the regional joint venture project for automotive, which just ended, by the way. And it's very difficult, as many of you know, trying to get the payments through the system. I could pay high school faculty directly, so they got paid on a 1099. But for college faculty, this has to go through your boards and through the processes that you all have internally. So I apologize that it is such a complex, problematic approach, and I wish I could do something more directly. But this is now under discussion at the BACCC level to see if we can come up with a regional solution. But my thought is that perhaps the local colleges can pay you directly, so you don't have to wait months while things get redirected, et cetera. So if you have any questions about that, please let me know. I will be using the records in the Zoom program for the training certificates. I'll be doing the training certificates after the April trainings are completed. And if you participate in all 4, you'll get 8 hours of training for those certificates. So we'll touch base on that one going forward. But thanks for your patience and understanding on the compensation. It's never an easy issue. Some of you have yet to be paid, as I understand from your own home colleges. And that really is unforgivable, quite frankly. I apologize for that. Kurt, thank you.
That's nuts. The good thing is you do get training hours. And since most of our schools are ASE accredited, they count for that. So not all is lost. Purpose of the webinar. Well, we all know the hands-on would be best, but that's just not going to happen right now. So again, trying to give that gap between how the systems worked and the components in those systems, and then the hands-on calibration, kind of built this out to be, whether you want to call it a prerequisite or an introduction to calibration, just more depth and breadth on calibration that we were able to do in the summer sessions. You are going to get access to the video, just like before. You're also going to have the PowerPoint presentation with a bunch of slide notes inside of it, links and things like that. Some of it I'll talk about in this, some of it I won't, but it's there for you to access. There's also some handouts and stuff. I scoured around, found some work process things, a couple of things that I built. There's actually a really good Toyota SIB that goes into floor slope calculation and things like that. And I was able to pull that calculator out and drop it into a PDF as well. So I'm going to submit all those things to ATL. They'll go up to the ATL site just like before. So you can go to that atleducation.org site. You would click on faculty, hover over the curriculum area. And I don't know exactly where she's going to put it, but I think they'll probably put it into the online ADAS training again. And you'll just find it there, which is the same location as all the other videos from the summer and the handouts and stuff like that, anything that was associated with those. So Also, don't forget iCar, Autel, Bosch, Snap-on, almost all the equipment providers have quite a bit of stuff out there. And if you have a manufacturer program at your college, you also have the factory information that you can probably access as well. So we're starting to see a little more availability because the realization's hitting everybody really hard on the need for it. I had some feedback in some sessions I had done for another group. Larry Rialta, I forget how to pronounce his name, with CEC. He's a non-technical guy, but he has a lot to do with all of our lives in that he has a lot to do with the funding when it comes to CEC grants for a lot of our programs. And he, not being technical, kind of got lost in acronyms a lot of the time. So his big recommendation was, hey, make sure you've got an acronym list in there for things that are applicable to the non-technical people that might be coming to your things. And as we start to talk about newer technologies, whether it's ADAS or more electrification and things like that, you're probably going to have more people start to look over your shoulder a little bit trying to find out about that because they're buzzwords. So having some of that included in there helps them out as well. So just a word of advice. It was something that I didn't do much before either, and I'm trying to do more of. So let's do a quick review on ADAS. Remember, ADAS, the intent is to increase passenger safety. And we're going to do that by increasing driver awareness via visual, audio, or tactile warnings. And with some cases, it might take over some control and make some corrective actions. We're going to have an awareness of our space based on cameras, ultrasonic sensors, radar, night vision, LiDAR, maybe more and more in the future, to give us the vehicle an idea where it is and what's around it. And if we take that a little farther towards an autonomous, you start adding things in like satellite, millimeter mapping, vehicle to everything kind of communications. And now the car has a better idea where it is, what's around it, and add some more hardware, add a bunch of software, and you're autonomous. Sensor fusion, we talked briefly about. Even though a system, say like active cruise control, is primarily looking at that long range radar, the cameras are still on, medium range radar is still on, ultrasonic is still on. All of these things are still there. To make the assumption that the system is only looking at one thing, it's kind of crazy. It still sees all of it. It's just a case of how much of it is it paying attention to. So yeah, the system could be written to only look at that. But as we know, as these get more and more advanced, the logic says, hey, look at everything all the time and include what we need to include and prioritize what's best prioritized. So sensor fusion plays a bigger part. If you can't see, the car can't see. That's something I like to think about. Weather conditions and ADAS are not friends. Snow, sleet, hail, ice, heavy fog. These systems, especially camera-based, they struggle with those kind of environments. Driving into the sun, we learned that, hey, with cameras, if you get too much white, the camera goes blind because it's too many of the same colors hitting at once. So if you can't see, the car can't see. Just something to keep in mind as we think about them. Calibration's critical. Little errors make big results. Something as little as 1 degree might have the car looking in the wrong lane because of the way the cone effect is from the cameras or the sensors. And, we've been talking for a few years now about the new basics. The reality is, if you're doing a newer car and you're doing an alignment, a lot of us want to think of it, oh, well, that's a fundamentals class. That's an entry-level job position. It is. But that entry-level position is now working on cars with ADAS, and that basic alignment now really involves an ADAS calibration. And what if you don't do that ADAS calibration? What's the liability impact of that? That car goes out, gets in an accident. They find out that, hey, it had an alignment, and there's no documentation that there had been the calibration done. Now, even that basic $15 an hour technician needs to have an awareness of that. So even in a fundamental alignment class, even if you're not teaching calibration, you should be teaching awareness of the steps to things like that. And then hopefully in your program, you develop in maybe a whole class for it, or find a way to manipulate that class to include it, at least at a demo level, because that is a new basic for us. A lot of this stuff is going to be, on everything. Not that long ago, we didn't teach steering angle sensors. Now that's part of an alignment. So think of a lot of these things in that same mode. Yeah, we don't teach this so much anymore, but now we have to add that. So something to think about. Documentation. We're talking about a high liability issue. We all see the TV reports. There was one like 2 days ago, a Tesla that drove under a tractor trailer. Was it on autopilot? Was it not on autopilot? Is the driver supposed to pay attention? Were they in the backseat making out? Who knows? But the reality is, if we touch the car at a service facility, we've automatically assumed a level of expectation, both legally and from the customer standpoint. We all know you replace a set of wiper blades and the engine blows up, it's your fault. That's just the customer reality in our environment. So if you did an alignment, or maybe you were in a collision shop and you did body work and you didn't correct these things or didn't go through the calibrations, you have an issue. So documentation is huge. Regardless of what state you're in, there's almost always some sort of parameters requiring documentation and the savings thereof. It's a liability issue. So when you're doing these things, you're going to want to make sure you document what you did. Why did you do that calibration? Well, we did an alignment on the car, or we replaced this. Why did you do it? Was it part of an associated repair? What directions did you use? What steps did you use? What equipment did you use? And printouts. We all know, after you did that alignment or you did that wheel balance, attaching that document to it, that picture says 1,000 words to the customer. Well, same thing with those documents at the end of that calibration. It will give you some information. Now, we don't always have the information to decide, okay, did it change anything? Did it not change anything? It just says it's okay. And that's what you want, because you put that on the document and the system said it's okay. And as long as you followed all the stuff you're supposed to follow and document it, you're as covered as you can be in California with our lawyer, or with our courts and judges, right? When do we do calibration? Well, calibration, by now we've got an idea. It's fairly involved and it's going to take time. It's not a flat rate project. So it is something that you don't want to do it as a maintenance item, that's for sure. Okay, so when are we going to do it? Well, fault driven. I've got a fault in the car and it's telling me because of that fault, I need to go through calibration. That's legitimate. If I've completed repairs, maybe I had a camera that had gotten broken, or a radar sensor that had gotten a rock through it. Well, obviously I would need to do it for those. Those are pretty straightforward. If I had done other repairs, maybe I did that alignment, maybe I did a windshield or a bumper, maybe the car was in a collision, things like that. What if I changed the vehicle height? I raised it or lowered it. Now I've got a calibration issue that I've got to deal with. Now, we're not going to get into compensation of or anything like that, because there really is no specification that says if you lift the truck this high, you redo these. That's a whole nother ballgame. Okay. If I was directed by a field engineer, so if I'm working in a dealership and the car's having whatever kind of issues, we all know that sometimes the field engineers or whoever that representative is will sometimes tell you, okay, go ahead and run this calibration or do this process. And finally, service bulletins, campaigns, recalls. Notice I didn't say just because the car is 5 years old, let's do this. At this point, there is no scheduled maintenance or scheduled calibration for ADAS. It's really more repair diagnostic based, and it's time consuming. So the cost just doesn't justify doing it as a preventative maintenance thing. Okay. Impact of alignment. 1 degree on the thrust is 5 feet at 100 yards. So when we look at that, if I'm thinking 100 to 150 yards out on an active cruise control, I could be looking in the opposite lane and not even seeing all of the car in my lane. Or if I'm on an undivided road, I could be looking at the lane on the other direction, and that car could be reacting to those other vehicles. So it doesn't sound like much. A lot of the time, if you do alignments, oh, 1 degree on the thrust, you're not that bad. Hey, green's good, let's go. No, 1 degree, when you think of that tunnel going out, that cone that ever expands, that becomes a big deal. Or 1 degree on the vertical. Now you're changing how far out that's casting. Well, if that happened to be, let's say, on a radar, and that's the main component of, say, my emergency braking or my pedestrian protection, I might see that person in time to stop. I might not see that person in time to stop. So 1 degree is a big deal, real big deal. And with cameras, they start talking pixels on those adjustment levels. So we're probably fractions thereof. Okay. So I've hurt your brains for a little bit. Let's see if we've got any questions popping up in there.
Not yet.
Not yet? Very cool. Well, you don't get off easy though, because I have questions for you. So why is documentation critical when performing ADAS calibrations? And I'm not going to make you answer them. I thought about making it a poll, but I'm just not that smart to figure that thing out. The nice thing is you can use this in your class. So when is it, when would you need to document it? Well, liability, obviously. Reference in case of future issues, definitely. State requirements, oh yeah. So all the above. So if one's good, two's better. When's ADAS calibration needed? Well, if I do a windshield, believe it or not, if it has a camera, you're supposed to do calibration. The theory is you might have bumped that camera by accident. Even though the camera is typically not adhered to the glass, it's usually adhered to the roof line, the chances of it being bopped are high. And so the manufacturers basically say, if you've done a windshield, they want you to do alignment. What about if I'm doing a headline alignment? No, at least not yet. Maybe down the road, they'll put cameras in the headlights or something, and we'll have to deal with that then, but not today. Vehicle thrust change. Yes, definitely. We just talked about that. Turn signals don't reset. No, not today, not for ADAS yet. Okay. Collision repairs, most definitely. As directed by a bulletin. Yeah. As a maintenance item, not yet. And what are potential results of misaligned cameras or sensors? Well, safety systems might not respond correctly. Makes sense. Airbags might not deploy. Well, we don't have the airbags on the radar or the cameras yet, but down the road, you never know. Systems may experience false positives. Yes. If I've got the cameras off enough or the radar off enough, it could react to the vehicles in the other lanes. It could react to lane barriers. If it's not seeing the right thing, it's giving a false positive and causing the system to react. Now, this last one I want you to think about for a second. Cruise control will be inoperative. So, if I didn't have my camera or sensors, depending on the system, correctly calibrated, would that affect the cruise control? And I'm going to say it's a yes and a no. It's a yes. I like Robert's laughing. Yeah, it's right either way, right? So it's a yes if you're in the active cruise control mode, to where it needs that camera or it needs that radar to provide that function. But the majority of the cruise control systems, even the active cruise control systems, they typically also have a cruise control function, non-active. So you might physically have to switch it over in the dash or something to not active cruise control from active cruise control. So in that scenario, the cameras might affect the cruise control. It might not affect the cruise control, depending on which function you're in at that time. So that's one of those trick questions that the students always hate. All right. No other questions pop up? Oh, you guys are easy. It's Friday. Shop space. When you look at a lot of the documentation, they're going to give you a generic spec, 16 by 30, 16 wide by 30 long. And the idea is that's the box that you would set the vehicle in, and it will usually provide enough space to have the appropriate targets, mats, deflectors, all that kind of stuff. Now, if you're talking a truck, obviously this floor print gets a whole lot bigger, but it still has, you know, that box type mindset. Now in this picture, this is a picture we took out in our shop, and the blue tape line is actually 13 by 30. Because to go to 16, I'm in that rack that's right next to the box and that the car is sitting on. Now, does that mean I could not do calibration in that space? No, absolutely not. But could I have problems with some calibrations? Yes. And that's primarily when we start talking side cameras, where I've got mats laying on the floor next to it. That might take it out of the box. And that's where that extra 3 feet would be a problem. Now I can, depending on what I'm doing, move the car in the box. So if I'm kind of tight on front to back, maybe I get to the back of the box as much as I can to give more room in the front and vice versa. If I'm doing side cameras, if the system allows me to do maybe one side at a time, hey, I move the car over to one side of the box, get my targets down, do it, move the car to the other side of the box, do it. So really kind of depends on what you're calibrating as to what you may have to do in the box. Now in my scenario, I've got 2 lifts. There's 2 cars right there. They're both sitting on ground lifts. And well, can you say, well, I just take the car out and lay the target over it? Well, the challenge with that is those stick up about 3.5 inches off the ground surface. Would that height difference and having the target mat lay over it compared to the other side of the vehicle where the target mat might be flat on the floor, could that height difference affect camera calibration? Yes, it could. So that wouldn't be a good thing to do, but maybe moving the whole car over farther in the box to where the mat laid in between the lift points, I might be able to do it in that space. So you got to be creative, because when you stop and think about most shops today, if you walk into a dealership today, you're not going to find a 30 by 16 empty place of floor except for right in the middle of the driveway to pull into the stalls. And they're probably not going to want to have a car sitting out there for an hour going through calibration while people are trying to pull in and out of their stalls. So I just saw a quick one pop up. How flat does the floor need to be? Think of it more on the angle. Most of the time, and we'll talk about it here shortly, when they're talking about floor slope, usually that number is less than 1 degree. So that's from the pitch on the floor. But when it comes to something like this with the lift arms and stuff like that, there really is no specification for that. To me, I look at it as that's going to be a depth difference from the camera to the floor versus the camera to the top of that lift plate. So to me, I think that would be a problem with the cameras. Am I going to find that in writing anywhere? Probably not, but I would want to play safe. So I can still do a lot of stuff in my box, but I do have to have enough box to do it. Shop preparation. So again, the generic size is 16 by 30. They want the vehicle positioned primarily in the middle of the box. And the idea with that is that way you can do everything around it. So you can have your targets in the front, your targets in the back, your targets on the sides and such. I saw Ruben's pop up. What I mean is, how much can you compensate for 1 degree? It depends on the vehicle. And I'll show you a Toyota thing here on the next slide, where they actually go into a process to where they measure a floor slope, and they have a calculator that you could type in, and it will give you some offsets based on that floor slope. But that's, again, for a Toyota. Now, some of that's just generic geometry. So how much application there is towards other cars is probably quite a bit. It really depends on the system as to how much tolerance there is. And that's not a number that they give you. You know, the manufacturers don't come out and say, hey, everything's a plus or minus 3. They don't give you that. There's no green is good. And I'll show you some results. It gives you some numbers, but no point of reference of, did it change something? Is that good? Is it bad? They just don't go that detail yet, and they probably never will. Okay. So again, our slopes, our uninterrupted workspaces, lighting, and we'll talk more about this in a minute, but lighting plays a big issue because of cameras, because of shadows and things like that. And also reflective surfaces can be an issue. And we'll show you a couple more
Two more
things.
questions. In terms of the car's angle and slope, how accurate does the car have to be in the box relative to front to back and side to side?
Basically what they're saying is it's a maximum of 1 degree floor slope is kind of that general thing when you look across a bunch of different things. So if you've got a vehicle that's got a heavy slope one way or the other, you might not be able to compensate for it. The Toyota video I'm going to show you next, it actually has a way for a calculator that they have built to be able to compensate for floor slope. But you're not necessarily going to be able to go find a repair instruction somewhere that says, if your floor slope on the right front is this and the left rear is that, this is the calibration offset. I haven't seen that. The closest thing I've seen is this Toyota video that I'm going to show. So they're really looking for, I would say a horizontal and vertical slope that's less than the 1 degree. Okay. So let's take a look at this. So this is the bulletin number for that Toyota floor slope calculation. This is one of the things I'm going to submit up to ATL to post up, so you'll have access to it. But I think I found it in Shopkey or AllData or something like that. You can Google search the internet; it's out there quite a bit as well. This particular video is specific to Toyota, but again, angles and such are kind of generic. You could probably use to some extent the information that'll come from it. You can also look up floor slope calculations online. There's a lot of different ways to do it. Some of the headlight aimer assemblies, the roll around ones with the eye, they'll do floor slope, and that might be another way to do it is set each up stall, whatever you're going to use, using that so you can determine the floor slope front to back, left to right, both on the front axle and on the rear axle and stuff. And again, there is some applied math, and I've got these links built into the show slides. So let's take a look at this video. It's a few minutes, and there's a couple spots that are a little fuzzy. It's the best I could pull down.
To accurately set the vertical angle of the millimeter wave radar sensor, you must determine the floor slope. The slope of the floor is crucial and must be measured accurately. A difference in floor elevation less than can be seen by the human eye will affect the vertical angle of the sensor and requires compensation. There is a slope angle calculator provided with the technical instructions that will help you determine the vertical angle adjustment once you have taken your measurements. Set the self-leveling laser up, facing the side of the vehicle far enough away that the laser will project a line that extends the length of the vehicle and through the vertical center of the front and rear wheels. Measure the distance from the floor to the projected laser line at the vertical center of the front wheel and rear wheel. Repeat the process on the other side of the vehicle. Enter the measurements into the slope calculation sheet. Ensure you put the correct values in each corresponding location. Press the Finalize button after inputting the values, and then press Calculate. The calculator sheet will automatically calculate the vehicle angle and provide the correct vertical angle the millimeter wave radar sensor should be adjusted to. It will also calculate the reflector height adjustment required based on the floor slope.
So that last little part where they said it provides the amount that millimeter wave radar sensor needs to be corrected to, that's Toyota specific. So I don't know that same thing would work 100% on a Chevy or anything else, but being able to do the calculations of your floor slope from side to side. So when you think about it, it's giving you both the side to side and the front to rear with that calculator. And that's about as best as you're going to get. And it's probably as accurate as you're going to get. I know Robbie posted in there, how accurate does the car have to be in the box relative to the front, back, and side? You want to be as straight as you can, because ultimately when you set up the tool, you need to be as parallel to it as you can be. So the straighter you are, the better. And with the floor slope, making whatever corrections. But if your floor has too much slope, you might not be able to correct. Okay. And I'll hit a couple of these questions because they're popping up. Should tire pressure be checked? Yes. And we're going to cover that here in a couple of minutes. Are those lasers self-leveling? Or wouldn't the floor also cause an issue? It's actually a self-leveling laser, and I looked them up. You can get them at Home Depot and things like that. They're $200 or $300 for a self-leveling laser. So even if you had it on a tripod, the laser itself will level off of its mount. My shop floor looks like a tank trap. Yeah. And that, I think, is a lot of reason why some places are still going to farm out work, some dealerships and things like that, because their floors are just not in a situation, whether it's physical space ability or because of slope and stuff, that they could do these things. And doing it outside has its own challenges because of lighting. And we'll talk about that here in a second. All right. I think we're looking good there. Impact of lighting. Now, lighting you wouldn't think is being a big issue, but remember, we're using targets. And if we're calibrating a camera, lighting becomes a big issue. Remember, too much light, too much brightness, too much white provides too many colors of the rainbow coming into the sensors at once, and basically the sensors go blind. So this picture is from Scott Brown Diagnostic Network. And what he did is in his own shop. So the pictures on the left are the targets. The upper picture is the target board in his own shop. The picture below it and to the right of it are pictures that were generated from a, can't think what you call it, a demo tool. So basically he's got this little demo camera and program that allows him to kind of replicate what the camera on the car would see. So he could mount that underneath the car or underneath the camera and kind of look out and see similar to what the cameras would see. So when you look at that picture on the left, you kind of see on the target, you see how all the dots are whited out and everything's visible. Then he turned on another light bank that was kind of behind all of this. So this target, there's some shelving behind it. He turned on the set of lights that was behind that and took that picture again. And all of a sudden, it changed what the cameras saw. So being aware of your background and your foreground and your lighting comes into play, because you could be washing out some of the target so the cameras won't be able to see it properly. So when you're looking at your shop space, one of the things you've got to realize is what are going to be lighted areas and reflective areas. So this is my shop with that same area with our blue boxes still on the floor. So this is to the north side of it. There's a bank of windows there. Luckily, they're north facing windows, so I don't have direct sun. That's not going to create a big problem, but I can pull the shades down. This is directly east. Now, I don't have a light problem here, but I might have some reflective problems down the road because of windows and things like that. And from the back of that box, I have a big roll-up door that's a big white roll-up door. There are shops that when they run into these problems, oftentimes they'll get big sheets of paper or just, bed sheets and things like that and cover up some of bright surfaces or windows or whatever. So you may have to, depending on where you're doing that calibration, you may have to compensate for reflective surfaces, for lighting. You may have to turn lights on or turn lights off to be able to have the right amount of lighting for the calibration to work. So if you're having a bunch of calibration problems, it might be environmental, not so much an issue with the camera or your equipment. It just might be too bright on the targets. So these are some things that can come into play with the shop environment. All right, I think we've hit a lot of the questions as they've gone so far. So I think we're doing okay. Everybody okay so far? All right. So you don't get off easy. I have questions for you. So what could result from having insufficient workspace when performing the calibration? Well, I might not be able to meet the right distances. What you're going to find is when you're doing these calibrations, typically there's two steps to it. You're doing in the case of the cameras, you'll do a very up close, and then you'll actually move the targets back and do a second one. So it's doing two different calibrations, seeing the target two different ways. So if I don't have enough space, maybe I can't have the targets far enough away that I need to have them, which means I might not be able to do some of those calibrations. Or maybe I have to move the vehicle in the box, which is one of the last things you really want to do. You don't want to be moving the camera or the vehicle around, because what if my floor's got a little bit of slope and I've got it in the best spot and now I moved it? And did I turn the wheel at all? Did I change anything to where now everything's out of alignment a little bit? I can have some really strange things going on there. How could excessive floor slope affect the calibration? Well, we already know that it can cause camera or sensor misalignment. I could have vehicle wander. That has nothing to do with this. Steering wheel might be misaligned. That has nothing to do with this. But it might fail to calibrate. And 2's good, 3's better. Which of the following could impact camera calibration? Well, direct sunlight, bright shop lights, and reflective surfaces in the target area. So if I've got, a big shiny metal cabinet and I'm trying to do radar, there's a chance it may have an impact on that. Okay.
So Kurt, John Taylor has a question.
Yeah, I saw that one. So white
Okay.
and black can both be reflective, as is painted surfaces. What's best? I couldn't answer it. Most shops, we usually have them pretty bright and white. And I think it has to do with the material more than the color. If I've got a big polished up sheet of white stainless steel or something like that, that's going to have a higher reflective surface than a wall, over wallboard. So I think it's going to be dependent. If you start getting a lot of really weird stuff, I'd say, put some pieces of paper in the background behind your target and see if that changes it. But I don't think there's a particular color or surface type other than, don't have a mirror there, for sure. That's going to do some weird stuff. But any metal surface, if you're talking the radar, you're now talking the reflective point. And those targets are looking for a certain reflection at a certain distance. But if you've got a bunch of stuff right next to it that could be confusing it, or if you're far enough out of calibration to begin with, you might not even be shooting at the target. You might be shooting at that wall that's reflecting it. I think that's the bigger part. Okay. Yeah, so far so good. Equipment preparation. Well, you got to have the right stuff. So you're going to find if you buy the Autel one, I'm not kidding you when I say it comes in about 4 pallets and 62 boxes. And we spent a day unboxing. It's crazy. And one of the pallets was 12 feet long. Wow. So it's an awkward mess. But you've got to have the right frame assembly, because that structures everything off of it. It's going to have a series of lasers, power supplies. You got to make sure the batteries are charged. Everything's charged up, because if it's not working, you're not working. Okay. You've got to have the applicable targets. And when we bought it for Chabot, we bought the master set, which was everything in the kitchen sink, because we knew we were going to be doing these classes and stuff, and we were going to probably be doing some regional based training and stuff. So we thought, okay, let's cover as many different vehicle situations as we could. But if I'm in a school, hey, I'm probably going to buy the base unit and whatever targets I need to cover the cars I'm going to use. And if down the road I add other cars, then just buy those additional targets. You don't necessarily have to buy everything in the kitchen sink up front. And guess what? As new car comes out, they're going to come out with new targets. It's just the rule of tools, right? So you're still probably going to buy stuff down the road. How much of it do you need? Depends on what you're doing. Okay. You're going to need a plumb bob and a string. So you thought you left the construction industry to go work on cars. Nope, you're still in it. So you got to have a string and something with a weight with a point on the end of it. I couldn't find mine. We did ours with nuts and bolts and pins and all kinds of stuff. Actually, it ended up being a multimeter lead end. because, hey, we were doing it that day. And really, I just needed something heavy with a point, because you do find the center point in the car, which we'll go into the strangeness of that. Scan tool. Pretty much all of these different calibration units have their own dedicated scan tool with the software in it. Make sure your software is current, obviously. Things do change. And you're really going to be following along in the directions on what the scan tool is. And what I found is the directions in the scan tool really aligned with what the same information that was in the all data in the shop key. So it seems to be pretty consistent. I don't think that the aftermarket guys are going to play around with that too much, because the liability could push to them, if they rewrote things differently. So keep that in mind. Applicable alignment equipment, if you're doing that in conjunction, that's going to be obvious. You got to make sure that thrust is in the ballpark, just so that you can be sure, especially from a teaching environment. And then going through making sure the vehicle's centered correctly. And this is one thing that we found was kind of interesting when we did it, is you can see on that bottom picture, it does bring up, what target frame and all that kind of stuff to use. And the car we were doing was a 2020 Hyundai Elantra with the Ultimate package. So it has all the bells and whistles and stuff like that. But it did come up with some interesting steps. Okay. If you're doing cameras, it's going to be a target of some sort. If you're doing the side view cameras and such, these are the mats that I was talking about. And this is where your stall width becomes an issue, because you're going to want those laying flat on the ground. If one mat was higher than the other, that camera calibration isn't going to be correct. So you really need those to be flat on the floor. A lot of cars at the moment don't have a lot of side cameras to deal with, but going forward, that's probably going to grow. If you're doing Teslas, you got side cameras. Okay. If you're doing night vision, it's actually a vertical stand that comes up. And depending on what type of camera on what vehicle, there's a bunch of different targets that come into play depending on the application. So again, you buy what you need. Don't buy the kitchen sink unless you have the money to do it. When it comes to the radar targets are different. They tend to be a metal target, reflective surfaces. You will have reflectors that you use when you're doing some of the setup and calibration. If you're doing the corner units, it's got this funny little cone or pyramid, inverted pyramid that you use when you're doing the side radar and things like that. There's different plates, and the repair instructions will tell you use target blank, blank, blank. So you have an idea what it is. They should be kept clean, Windex or something like that is more than enough, because they are reflective. Now, if I had this right next to a big metal surface and my radar was way off, I might not be able to calibrate. Okay, and we had that discussion before. What if I dropped it and dented it? This is something you got to think about. Remember, the radar is producing a signal that's going to hit that target and reflect back to the radar for calibration. If I put a little ding in it or a little bend in it, is it going to reflect the same way? Because that sensor is looking for a certain amount of return, because it was told in its book of rules that you shoot at this target, you're going to get this return if everything's in the right space. And then they would have to adjust the unit physically to compensate for that. Well, that little dent is now sending something over that way that should have been going that way. It's not going to calibrate. So you got to treat the targets with care. And that's probably going to be one of the weaknesses for instruction, is we all know students can drop everything. So that chance is there. Also, when it comes to that stand, and let's see if I can get my highlight to work here without changing slides. This stand, that footprint is like an 8x8 little box. So it's probably not the most stable of things. So as the students are walking around that in the shop, or, fat guy like me walking around it in the shop, it getting bumped, it's got good potential. And that cone gets dinged, it's not going to shoot back in the right direction. So that's going to be an area that we've all got to be careful of, as the targets and the storage. of them. The soft targets are rolled up like a mat, and they go into a bunch of like fishing rod tubes. A lot of the steel flat targets, they're literally stored. They come in the Autel sends them in a great big aluminum aircraft type case that with the foam cutouts, and they drop in. So they're pretty protective in their storage side, but it's when they're out of that, that's when they're at risk. So let's go into vehicle preparation. Now,
For 1 second,
go ahead.
I have some real-time intelligence here.
Okay.
So we had 2 questions about what color should the area be where you're calibrating, especially for John Taylor and for Steve, who are building out new spaces. I texted Steve Zach.
Okay.
So for those on the call, Steve Zach is at Bosch, and he's been a tremendous resource for all of us. He says that the color that you choose, the paint should be a flat, light colored paint, like a manila or light gray. And in the back, he just sent us an update, and there's some material listed in the back pages, so I'll send that out. But the shiny white reflects too much, and dark absorbs too much color, and you'll have problems with shaded areas if you choose darker paints. So manila or light gray flat is the answer.
Very good. Steve's bored. He answered that quick.
Yeah, he's hanging on to every word you're saying, Kurt.
He's retired. He's enjoying it.
Exactly.
He's hoping someone picks up the call. It's cold up in Vermont or Connecticut or wherever it was he was living.
Connecticut, yeah.
No, perfect. Thank you. So John, now you know what to tell the guys to paint the walls. So that, that fuchsia you were looking for, just not going to work.
Yeah, forget fuchsia, John. Sorry.
All right. So vehicle preparation, when we talked about this, when we were talking about the systems, the visual inspection becomes huge. Because if I've got collision damage or too much clear wrap or body wrap or damage on the glass or anything like that, that visual inspection becomes huge, because if there's physical issues, I can't calibrate. If that had a bad paint job and it's got too many layers of paint, that radar might not get through that bumper. Or if it's been patched up with filler, it can't get through that bumper. So that walk around becomes a big part of this process. Tire pressures, tire size, tire wear comes into play, because when you think about it, we're changing that vehicle's angle. So yeah, floor slope is part of it, but what's the condition of the car? Have we got plus size tires, minus size tires? Are they unevenly worn? Do we have the junkyard special where you get 4 tires of any choice? All of that comes into play. Vehicle ride height. You may have to sandbag vehicles to compensate for fuel load, to compensate for sagging or aftermarket, whatever. So the vehicle ride height becomes an issue. Now let's be realistic. We raise cars, we lower cars, cars get old. Are you going to be able to properly calibrate that modified vehicle or that vehicle that needs other repairs? You might be able to calibrate it, but is it going to be correct? Don't know. And the manufacturers aren't going to give you any kind of a parameter to say, oh, if you put this 4-inch lift kit on your Jeep, here's the calibration offsets. They're not going to do that. So that creates a whole new level of challenges when it comes to calibration with modified vehicles. If I've got a vehicle that, it's a traveling salesman and he carries 800 pounds worth of stuff and the springs are shot, I'm not going to be able to calibrate it correctly. I'm now having to sell this guy suspension work to make his radar work right. That's going to be fun. So keeping all of those things in mind, that ride height is critical, and it starts with the tires. Making sure that I have a sufficient power supply, because the key is going to be on, you're going to be in a key on engine off situation for pretty much the whole time you're doing this. So having a power supply on the vehicle, which is its own challenge, because if you're doing the camera, you can't have the hood up. So now you got to string that thing through the hood. If you're doing the radar, you could probably get away with that. Ignitions conditions, again, key on engine off. What if it's a hybrid or an EV? Well, I'm in ready mode, okay, because I need these radars to be able to be active. The only time they're going to be active is when it's going through the calibration. When you tell it calibrate, it's now shooting the radar. Don't walk in front of it. You're not going to nuke, but you don't want to live there in front of it all the time either. Okay. Following the directions. Can't say that enough. Follow the OEM directions if you have them. And if you don't, you're following the calibration stuff for the tools and equipment you have, shop key, all data, all that. Now for one of those student favored trick questions. Do I need to calibrate the steering angle sensor? Let you think about that one for a minute. So let's think about this. From an ADAS calibration standpoint, I don't need to calibrate the steering angle sensor. But for proper operation, I do. And this was a surprise to me too. I was sitting on another person's call one day and they said, yeah, a steering angle sensor could impact brake wear. And I'm like, oh, come on now. You gotta tell me what's going on with this one. So think of it this way. A car with stability control. We drag a brake in corners quite regularly for stability control. That's one of the ways they control it. Well, part of those inputs to make that determination if I'm going around a turn is steering angle input, lateral accelerometer, wheel speed sensors. So if my steering angle sensor is out of whack, could the computer be getting some false information and making some corrective actions associated? Possibly. Well, how do we apply that to an ADAS? Lane departure, lane keep. If the lane departure, lane keep is getting information, because we know it's going to get that information, not just looking at a camera. We're still going to have sensor fusion in play. So if I'm seeing this steering angle turning left all the time and the cameras are seeing what they're seeing, would it be possible that the ADAS could look at that and say, I need to do something here because of that? Not saying it does. I'm just saying, in my mind, there's that possibility. So don't read into it. Kurt says, go calibrate steering angle sensors. They should already be calibrated. But just think of the ramifications from it. We went through this with OBD2 when it first came out. Hey, I put a new sensor in and it runs worse until it relearned. Well, it's information. It takes information, it looks at its book of rules, and it tries to make a decision. If that information's wrong, it may make wrong choices. Okay, so that one surprised me too. So I thought I wanted to make sure I shared that one. It was different. So let's do our walk around. So here's my my lovely Hyundai Elantra, and let's see if this will work for me. And I just happened to start at the front of the car, and I'm going to look for things like those corners, right? Typically where my radar would be if I had the radar there, or my long range radar for my active cruise control, or over here. I'm going to look, does it have funny spots in it where maybe they did a bunch of filler because of a previous accident? Look at the edges. Does it have a bunch of clear protection wrap, or is the whole car a different color now because they wrapped it? I'm looking at my windshield to make sure, hey, I don't have any cracks in that window box that's going to affect that camera. Okay. Do I have any ripples in my A-pillar or in my roof line? Does it all look like the same paint color? Because maybe this car has been in an accident and then I'm never going to be able to recalibrate it. If I've got rear corner radars, typically they're going to be in these areas here. What's the condition of those there? If I've got ultrasonic sensors, because we use ultrasonic for more than just parking. Ultrasonic on ADAS cars is a near range envelope. It's that 6 foot less envelope. So ultrasonic may be going down the road on some of these cars, Tesla, for example. So same thing on this corner. I'm still looking at all of those kind of collision, repair, etc. based items that could impact it. If I'm a Tesla, I've got a camera right here. I've got a camera in the B pillars. Do my doors close correctly? Back into here. A lot of cars with the ultrasonics, they'll have a sensor over here on the side. They might even have a camera over in the side there on some vehicles. So all of those things become part of my walk around. And yeah, I'm going to look at my tires and my wheels, and does it look like it's sagging? I'm measuring my vehicle ride heights, all those kind of things. So that becomes part of that preliminary inspection that we're used to for like an alignment, not just throwing it on and going after it. Okay. I'll take a peek over here real quick. Robbie asked, how does lifting a vehicle come into play as to frame contact and wheel contact relative to suspension hanging and returning to its original? Yeah, that's a good question. And I would say it's probably the same kind of effects that you would have on an alignment. Until you settle it, you're not at your actual height and stuff. And most of the equipment now is set up to where they're integrating it in with Hunter stuff, to where you could be doing the alignment and then do the ADAS calibration while you're still in the machine. And there is some calibration offsets and things like that that can be done. And I've got a little video clip on that I'll show here in a little bit. But yeah, I would take that same mindset. If I had just lifted the car and I put it on the ground, I probably should pull that car off, move it around a little bit, pull it back up before I go into calibrations to make sure my suspension's settled, or at the very least, a lot of jouncing. But, you know, independent suspension cars, we all know that those tires can kind of roll under, and until it really sets and moves, they don't roll back the way they should be. So that's a really good point to bring up. It's a really good point to bring up. Information, specifications, and directions. OEM's best, you know, so if you have access to it, first and foremost, that's what you want to do. It seems like from a couple of the cars that I've been able to find OEM stuff on and then find it in ShopKey and AllData, it seems like they've almost copied it word for word. Officially, they probably haven't, but maybe they did. Okay. iCar is providing a ton of information. iCar is the collision industry side of things, and they are really aggressively having to deal with this. So for them, they're producing a lot of information on their website. Takes a little bit digging around, but there is a ton of stuff there. And then again, the calibration equipment itself has information. Okay. Now, in the case of our Hyundai, it actually had us do, we were doing the camera calibration, and it had us do two measurement points. One is like 100 millimeters right off the front, and the other one was 1,000 millimeters off the front. But one of the first steps it has you do is kind of find a center line. And what we found interesting is we were following the directions in the Autel tool, and it had us use the plumb bob method. So where you were dropping a plumb bob down the front of the vehicle at the center line, down the rear of the vehicle at the center line. And if you're trying to find the center line, most hood emblems and stuff are right on the center line. So if you come off that hood emblem and you drop that plumb bob, you know, it gives you a little thing hanging down to the floor, put a piece of tape there, put a dot. Now you've got that center point. In this case, it had you do that in the front and the back. And then it wanted you to pull a string from the front of the car to the back of the car and pass that distance to give you that center line. Then it wanted you to measure off a certain amount to the right of that line and a certain amount to the left of that line. And we used tape to highlight that edge where the string would have been, so it's easier to see on a camera. But that was how the repair instructions in the Autel was having you do it, was via a plumb bob. What was interesting though, there was a video in there that said, you know, for assistance, watch this video. And we watched the video, and it says nothing about the plumb bob and strings. It uses the lasers. So that was a little strange. And I think the plumb bob is from right out of the Hyundai stuff, whereas the laser or the laser alignment was more of an Autel thing. So we did it both ways. We did it with the string, and we did it with the lasers. And what we found, there was such a nominal difference between the two of them, it wouldn't have probably affected anything. But it was rather surprising that, you know, it told you one way, but, you know, the reference materials was showing you something different. And I'll show you that video here shortly. So you're just following the steps, but you've got to take your time. That's the biggest thing with it. You've got to take your time. I know when we first tried to do the camera calibration, misinterpreted it, did it wrong, and it failed. Thank you very much. And then when we reread it and understood it better, we did it the right way, and it worked fine. And that's going to be the learning curve for everybody. This first few times, making that mistake, misinterpreting it. The good thing is the system will usually fail, and then you can go back and do it again. So let's see how we're doing. We've been hitting most of the questions as we go, so that works out good. So you have none for me. I still have questions for you. No free lunch. So which of the following is not correct? Well, targets, they're application specific. Okay. That doesn't mean you need a target for every Honda made. All right. There are targets for Hondas that might work on other cars too. Vehicle ride height can impact calibration. Most definitely. If you're too low or too high, front, back, left, or right, it's crooked. It's not going to see straight. Incorrect collision repairs. Yeah, that's going to be a problem. Calibration target distance are universal. No, they're application specific. So the directions will tell you how far away to set the target. If you just say, oh, they're all at 100, yeah, a lot of them might be, but what if yours isn't? Maybe you're not seeing it anymore, or maybe it's getting an incorrect signal. Hopefully the system would say, nope, no calibration, that's not right. Worse yet, it might calibrate. And if it did and it's wrong, it's not seeing around it the right way that it should, and that's probably going to lead to some other problems. Which of the following needs to be performed prior to calibration? Engine at operating temperature. Wouldn't matter. Tire pressure set to the manufacturer specifications. Yes. Visual inspection. Yes. Steering angle sensor calibrated? Not at this time. Not for ADAS. It doesn't have to be, though we discussed how it might have an impact, but not a required calibration. Finally, where can calibration information be located? Manufacturer service materials, aftermarket service information, shop key, all data, etc. I didn't look in Identifix. I'll assume they probably have it too. Owner's manuals? No. Customer's not going to calibrate this stuff. Scan tool calibration software? Yes. And iCar. Okay. So this next video is going to come up. It's going to go through the setup on the Autel. And it's about a 6, 7, 8 minute video. But it's very good. As long as it'll play. There we go.
We are going to review the Autel ADAS calibration tool package and demonstrate the toolset placement for the calibration of radar and cameras used by such advanced driver assistance systems as adaptive cruise control, lane departure warning, blind spot detection, and night vision system. The calibration frame standard package comes with the adjustable frame, 2 wheel clamps with laser levels for precise calibration, and the Volkswagen and Mercedes-Benz pattern targets for lane departure warning calibration. The complete set of vehicle manufacturers' pattern targets for lane departure warning calibration is sold as a separate package for glass repair shops. The radar and night vision calibration tools and rear and surround view camera patterns are also sold separately, allowing the shops to order the tools based on their repair requirements. Set up and perform the calibration frame leveling procedure by following these steps. Park the vehicle on a flat and level surface with its front wheels pointing straight and ensure there are no objects in front of the vehicle. The vehicle's coolants and engine oil should be at recommended levels and the gas tank full. The vehicle should not be carrying any load, passengers or cargo. Attach the VCI to the vehicle and connect the diagnostic tool to the vehicle. If connected through cable, please pass cable through window. Close the doors. Adjust the tire pressure to the recommended value. These vehicle preparation measures vary by vehicle and system. Please follow the preparation instructions on the MaxiSys ADAS tablet to ensure accurate calibration. Step 1. Position the calibration frame. Place the calibration frame in front of the vehicle. No pattern should be attached to the frame. Rotate the knob at the back of the crossbar to align the two red marked lines. Rotate the top knob to move the ruler to the middle. Slide the crossbar sliding plate to the middle of the crossbar. Use the handle or depress buttons to set the crossbar level with the center of the front wheels. Power on the sliding plate laser and aim the laser at the middle front of the vehicle. Move the frame to the specified distance away from the vehicle. The correct distance of the frame from the vehicle may differ by vehicle manufacturer. Consult the help section on the tablet for the correct distance for that vehicle. Ensure both sides of the crossbar are at the same distance away from the center of the front wheels. Prior to powering off laser, ensure it continues to be focused at the middle front of the vehicle. Secure the frame to the floor by turning the 4 hand knobs to lower the feet. Step 2. Connect wheel clamps and lasers. Attach the wheel clamps to each of the rear wheels and continue to turn the knob clockwise until the clamps are tightly secured. Connect the laser to the wheel clamp with the laser board facing forward. Turn on the laser and aim it at the crossbar ruler. Rotate the knob on the top of the crossbar until both rulers have the same value lit by the laser. Step 3. Adjust crossbar parallel to the vehicle. Pull up the cover plates on each side of the crossbar. Adjust the laser to focus it at the crossbar reflector and aim the reflected beam at the laser board. Turn the knob at the back of the crossbar until both laser boards have the same value lit by the reflected beam. Now the calibration frame is parallel to the vehicle. Once the setup process is finished, initiate the calibration procedure and follow the instructions on the Maxisys ADAS tablet. Attach the target panels to the frame accordingly for camera calibration, radar calibration, or night vision calibration. Please contact Autel Technical Support with any questions or visit our website, autel.com, for additional support or product information.
Now, going through that process isn't real bad. It doesn't take that long. The strange part is what we found is really at the beginning, it had you use that centering laser on the center line of the car. Well, when it has you move that beam, it's not in the center line of the vehicle anymore. So it offset it a little bit. So it's a little bit strange. It's trying to get the tool parallel, but it does change that center point slightly. And we ran through that a few times and it basically made no difference. We thought, oh man, it's all going to be off now. And it didn't end up being off. So it's just the steps that tool goes through to make that as parallel and squared up as it can. And like I said, it was almost identical to what the plumb bob and strings did. Okay. And I saw Augustus had chimed in there. Steering angle reset is part of a late model car's alignment, so it's a moot point whether needed or not. Exactly. Oh, then I went and made my thing here. Hold on. I'll blow myself up here for a second. Yeah, well, it's loose nut behind the wheel. Oops. Let's see here. The one thing about technology gets you every time. Set my string back all up here, right? I'll get going here again in a second.
You have to calibrate the screen.
I got to calibrate the screen. Too many buttons. All right, let's see if we can do this the right way. Let me get back to where I was.
Wow.
Yeah, we're running just a touch behind, but lots of stuff. Oh, it doesn't like to go out of that one thing, does it?
No.
All right, so I'm going to change it up here. We'll do it the hard way. Okay, so that was that one. Everybody can see this one okay? All right, we may run into trouble with the video, but we'll make it work. So all of those steps are part of the mechanical calibration process, okay? Now, even if you do mechanical calibration, you're still probably going to have a dynamic portion. A lot of these systems will do a mechanical calibration and then have you drive the vehicle to complete the calibration using a dynamic function. Think of that as separate from a purely dynamic calibration. If the vehicle had a dynamic calibration, I wouldn't have to use the targets at all. So this would be finishing up a vehicle as part of its calibration that started mechanically. That is completely separate from the road test. So if I do a dynamic calibration, it's to finish the calibration. Then I need to road test it to make it sure it works correctly. So those two are not connected. Think of the road test as a completely separate item from the calibration. So mechanical calibration on that camera, we started out about 100 millimeters from the front bumper, and then it had us pull back to 1,000 millimeters from the front bumper, and it gave us 5 minutes to basically move the equipment straight back, make sure it's recentered, and to complete that calibration. And when we did, basically it gave us this upper picture as results. And I know the angle's a little funny on the picture, but it tells you calibration successfully completed. Camera horizon calibration result, 3 pixels. Camera yaw calibration result, -2 pixels. Camera grabbing shift calibration result, 0 pixels. And finally, camera roll calibration result, 0 rad. Now, what does any of that mean? Have no idea. Is it in a spec? Have no idea. Is it out of a spec? No idea. Is it in a tolerance range to the high side or the low side? No idea. They don't give you that information. The key here is this piece right here. The calibration has successfully completed. And those numbers could be how much it changed or where it is. Just don't know. And I've tried to dig around as much as I can, and I haven't found anything yet. But I haven't made the emergency call to Steve. So maybe I'll try that and update people later. But again, if you do a calibration and you get numbers there, as long as it says successful, it's okay. We don't know what that tolerance range is. But they do give you some cautions. Be sure to perform the test drive to check for normal operation. Drive on a straight road of longer than 500 meters with 2 white or yellow lane markings at a speed of over 60 kilometers, 64 miles an hour, and check for the alert as you intentionally steer close to the lane mark. This particular calibration was more within the test plans for lane departure and lane keep. LKA operates properly if the lane mark segment space is less than 8 meters. Perform test drive on car only road or highway. So they're even telling you, hey, if it doesn't have good lane markings, it may not be able to properly function. And that is one of the challenges, is they're saying, well, some of these systems are getting smarter. They don't need as defined markings. But if it's finishing up a calibration, or if it's finishing or doing a dynamic calibration, it's really going to need those lane markings to be able to do it right. This next one is a video clip, and I'm not going to show it so that we can be mindful of time for you guys, but it's basically that Autel unit in conjunction with Hunter. So you can now use the Autel calibration unit with the Hunter aligner, and they have an integrated software that you can do some offsets. So if you've got it on a drive-on lift and it's off the ground a certain amount, you can give, it'll give you some calculations to compensate the target heights to be able to do that versus having to put it on the ground and take it off the lift. So they've gone to that extent. And so has Bosch. And I just found out about this from the Hunter guy like 2 weeks ago. Bosch has also gone into a partnership with Hunter and integrated their DAS system. So now you can use the Bosch system integrated with the Hunter alignment equipment to do ADAS calibration still on the rack after finishing up your alignment work. And again, this video links to that. You'll get this in the presentation when it posts up. I just don't want to take too much of your time today running us too late running these, especially since it's blowing up on me. Dynamic calibration. Now, some of these systems, you don't have to do a mechanical calibration. You're going to have to do a dynamic, which is basically drive the vehicle. But you have to drive the vehicle very specifically. So you put that car into a calibration mode, you drive the vehicle, and it's going to want to see certain criteria and certain parameters. We'll talk about those here in a second. It may be part of a mechanical. So this might be the second step after performing the mechanical calibration. That road test still needs to happen after the calibration is done. So if you drive it and you pull over and it says the calibration is complete, you need to go drive it again to make sure the system works the way it should. Don't think of calibration and road test as all in one. It's not. It's two separate things. And weather conditions can impact this. Remember, if you can't see, the car can't see. So rain, snow, sleet, hail, heavy fogs, heavy smoke and ash, all of those kind of things come into play, but so do the road conditions. Okay. So some of the general preparations for dynamic calibrations: have the windshield clean. That way the camera can see. Be sure the cameras and the sensors are unobstructed. Avoid lane changes. They want to see those lane markers as long as possible so that it can check the camera. Vehicle speeds. Now, this is going to be a hard one, especially in Bay Area and stuff right now. If you can get on a road and only be doing 56, you're lucky. You're getting run over by people doing 75. The reason is they want to maintain a certain amount of speed so that the cameras can acquire and view correctly for a long enough period of time. And then they also want you to have good lane markings. And again, this is so that it can go through its steps to calibrate. You might be able to have it function with less, but while it's trying to learn and confirm, they want to have more. Problems that you could have: heavy traffic. It's going to be hard to do this if you're bumper to bumper traffic because it's not going to see the lanes out in front of you. Again, thinking more of a camera at the moment. Stop and go traffic would be an issue. Windy roads. And where that comes into play is if you're constantly having to correct for the side winds and stuff like that, that lane departure may be getting a little confused as it's trying to look at all of its inputs. Poor lane markings could be an issue. Vehicle speed, if you're too fast, too slow, weather conditions, or hey, you just screwed up on the installation or the repair. Any of those things could be a problem for it to do a dynamic calibration. I'll poke over to the chat here real quick. Steering angle we talked about. John Taylor, so turning student loose on highway to drive vehicles at 60. Absolutely, John, aren't you? No, not even close. Green's good. Yep, you're right, Ed. Green is good. Ruben, my wife's Chevy Volt required a dynamic calibration check when the windshield was replaced, which is great because that way they didn't have to do a mechanical. It would have cost a lot more. But yeah, they're supposed to. If they do windshields and it's got cameras, they're supposed to do it, which now almost doubles the price of a windshield job because a lot of them are charging $200 or $300 or more to do the calibrations, and then giving you all the horror stories if you don't. Confirmation is another quick video clip. In this particular video, and it's fun to watch, they went out and they got one of those blow up fake car butts and parked it out there, and they had done calibration and everything, and they wanted to make sure the car did what it was supposed to do. So they hammered the gas pedal and went right at it. And guess what? It was calibrated correctly, it functioned correctly, and the car threw on the brakes and the emergency braking the way it should. What's interesting, though, is it actually happened very late, much later than you would think. So it gives the driver every chance to step on the brakes until it's too late, and then it buries the brakes. But it worked. So I guess now, John, we got to go out in the parking lot and try to rear end other cars in the parking lot to confirm that it worked. No, don't do that. Don't do that. Buy a blow up. Okay. I know Scott Brown has Bozo the Clown, one of those kitty punching bag things, and he drives at that. And some cars react and some cars don't. So keep that in mind. But yeah, it's scary. I don't want students driving into them. No, I don't want to drive into them. This one's kind of interesting. And this one's more of a collision impact thing, but I want you to understand how this could be associated with calibration. So this is from Scott Brown Diagnostic Network. This was a rental car he had in Georgia or something like that. He was going to a training and the active cruise was on and it started having some weird things. So we're going to look at this top left picture here. There's two things we want to look at. We can see that, SUV up ahead, and down in the instrument cluster, we can see the car has been acquired. So when you look at those two parallel lines, you see a little picture of the car, and just to the left of it's a green steering wheel, which means the active cruise control has acquired that vehicle. So it's going to maintain that time spatial distance. The picture directly below it, now this is a little sedan. And when you look, it didn't acquire the vehicle. They're at similar distances, but one acquired the vehicle and one did not. And he said it was kind of scary because if he hadn't noticed, the car was running up on that sedan pretty aggressively because the car never saw it. So they took it, and it happened to be an ADAS thing he was going to, and they started looking into it. And in the Nissan, the radar sensor for the adaptive cruise control is right under the front emblem, similar to Toyota and some others. And what they found as they went through it, it had some fault codes, radar stain, CMP cyst, OPR, OBST, which he figured was obstructed or blocked. So as they started going through some of these diagnostics, they started looking at that sensor more and more. And ultimately what they found was what's in this bottom right picture. The bracket's bent. And that sensor is now tilted backwards. They contacted the car rental company, explained to them what they had seen and found and who they were. And the car rental company had no record of that vehicle having any repairs. So there's a good chance that somebody rented the car, screwed it up, put a new grill in it, put it back. And it worked. It didn't have fault codes that were inhibiting the system, but it didn't recognize every vehicle. So what was happening? Well, it recognized the SUV because it was taller. Remember the cone? The cone went over the sedan, didn't recognize the vehicle. The cone went high enough to see the SUV. So in this scenario, yes, this was because of an accident damage, but if we miscalibrated, we could have that exact same scenario where the cone doesn't see where it should see properly, and it could miss that vehicle ahead of us. So it's a great example of just that little bit of angle difference works on an SUV, but it doesn't work on a sedan. So you can only follow SUVs with ADAS. No. Okay. Let's see what other things we got in here. Phil, yes, be careful, use pillows. Our Subaru Ascent failed to stop every time. Whoops. And that's not uncommon. There are a lot of cars, depending on the target that you're trying to run into to check that emergency braking, some of those targets just don't react. The car doesn't react to them very well, whether it's a reflective surface issue or a density issue or what. And some of that may come into play. Is it using the cameras or the radar or a combination of both as to how well it is seeing that obstruction? Ed Snyder chimed in. One issue I noted near Sacramento Freeway, the reflectors between the freeway lanes were removed and the wider dashed lines were used for the cameras to see at night. Wet freeway lane lines were very difficult to see visibly. Yeah. And that is something that was actually a federal thing. California started doing it a few years ago. They got rid of the little rumble bumps. They said it was a cost savings because the tape and the paint could go down. And when I was talking with Steve Zach and some other OEM guys, they all kind of said that's part of kind of the transportation evolution of having more standardized lane markings. In my area, a lot of our street lights, the black backing around the street light has a bright yellow or orangish highlight around it so that the cameras can see it better because of the light in the background and things like that. It makes it stand out better. John, he's still trying to kill off his students. You know, he's now got short pedestrians out there. And of course, everyone was filming it. Yeah. Oops. That's the best thing about cameras today, right? All the oopses. No. Good for American Airlines works like an SUV. Yeah. We get airplanes landing on freeways now. All right. So summary, trying to keep it on time as close as I can. Calibration is necessary part of the repairs. You've got to budget that time and you've got to sell that job. It's not an optional. Okay. Proper documentation, super critical. Without it, you're in trouble. You want that documentation, take the time. We all know the technicians aren't the greatest at writing job stories. This is one more reason that they need to. Okay. Preparation's key. You got to have the space. You got to have the equipment. You got to have the right vehicle from the training environment. And it's got to be uninterrupted space. You can't have it in the middle of the shop and people running through it all the time or trying to get out of a stall, because every time you move that car, you've got to recenter it with the equipment again. So once you set it up, it's there until you're done. Confirmation of the calibration via the tool and live operation. Get the printout, drive the car, confirm that it works. Don't assume a dynamic calibration confirms that it works. ADAS calibration, it's part of the new basics, guys. So even if you don't have the tools to physically teach calibration, there's a lot of videos, this kind of stuff. They need to be aware of it at the very minimum, and preferably building things in the future to where they're physically doing it. Okay. A couple more things. Josh chimed in. Kurt, does the brick pattern on your shop floor cause an issue? No, I didn't have any problems with it. I don't think it looks down at the floor to that level. And even if it's casting out, the targets are usually, you know, bumper height and stuff like that or higher. So I don't think the brick floor is going to be an issue any more than a painted shop floor would be in most cases. If anybody's got any other ones, just throw them in there. You know, and finally, you know, questions, guys. If you got them, throw them in there. If you want to throw a mic on and say, hey, go for it. But I really want to make sure we thank Pam because, you know, in the last 3, 4, 5 years now, you know, all the stuff she's done for us, you know, for our students, for our programs, for our industry, and all of us. I mean, amounts of training. We've probably seen 200 plus hours of training, much of it paid at the college levels in the last 3, 4, 5 years. Equipment, curriculum, you know, we're all benefiting from the insane amount of hours that she puts in. So I know I'm very thankful for being able to work with her and what she's done for our program. So I want to make sure she knows that.
Kurt, thank you. And I just want to make sure everyone realizes we're going through a very critical time for our industry and for our programs. Our programs are being hit by the technological acceleration that all of the vehicles are actually showing up with now, but also regulatory impacts. So electric vehicles are going to become more and more important. And one of our priorities is to rethink the automotive basics, as Kurt had talked about earlier. And we're going to be continuing those discussions in the upcoming trainings. The heavy duty side also is undergoing a major transition, and all of the faculty there are undergoing heavy duty electric training right now. We have a grant to get that process started. And hopefully a second grant that I proposed on for hydrogen fuel cell technology for heavy duty. So I thank you all for understanding that this is a very critical time, and your diligence and professionalism are most appreciated for us to make this transition going forward. So I just want to remind you of the upcoming trainings. We have 3 sessions coming up in April. I had to move some of them because of the very important SAE electrification certification trainings that Mindful Mobility Tech Talks is putting on. level 2 certification is next Friday at 1 o'clock. I'll resend that email out to make sure everybody has that in case you haven't gotten it. The level 3 certification is going to be on April 30th at 1 o'clock, and I'll send that link out as well. Consequently, I had to move some of the trainings that we had scheduled. So Mike Sherburne, instead of being next Friday, as we initially had scheduled, will be after Easter on April 16th, Friday at 1 o'clock. And Mike, thank you so much for doing this. On April 21st, Wednesday at 4 o'clock, different time for us. It's going to be Wednesday at 4 o'clock with Mike Hernandez from Evergreen Valley College. Mike has been overseeing the Tesla Start program there, and he's going to be retiring, which I'm very upset about. But he has agreed to share with us his thoughts about what our students need to know to actually work on Teslas. How do our programs have to be adjusted and modified to make sure that our students have the right training to work on these cars? And that'll also be the catalyst for a continuing discussion about how our programs need to change, what we need to, prune, trim back on, and what we need to add, which are very important discussions for all of you to think about for your programs going forward. And then the last Friday, not the last Friday, the second to last Friday, on April 23rd, James Lawrence from Monterey Peninsula College did something quite unique this past summer. He put together with the Arduino kits. Remember the Arduino kits I sent everybody? Well, in the college faculty in the Northern California region, not everybody, but just in my region. I sent them Arduino kits for Christmas after we had the discussion by level 5, how the Arduino kits could be used as controllers for electrical work. And James put together a unique take-home class for students during the COVID time that turned out to be quite successful. So he's going to share that with us on April 23rd. But if any of you have additional ideas for trainings that you'd like us to put together, please send them in to me. I'd love to put that together for you. And also before we go, just wanted to thank Kurt. Kurt has been absolutely tremendous in putting these programs together and being a continuing resource to all of us. And I just love the fact that he's so dedicated to all the new technologies that he just jumps right in to help us all out. So Kurt, thanks again.
Thank you.
So I will be uploading these training sessions onto the ATL website. As always, I'll send out that link to you. And if you have any other questions as they come up, just send them my way.
And
Thanks, everyone.
real quick one, Ruben had in the chat, he wanted us to plug the CAT virtual conference coming up on April 23rd and 24th.
Oh, great. Excellent, Ruben. Thank you for reminding me. Anybody else have some announcements?
I do have an announcement from Evergreen Valley College.
Great, Mark.
There is we're hiring a full-time faculty now. So if you go on the EVC site, and I think I've given that to you, Pam.
Yes, sorry.
And that is closing on the 28th. So if you know anybody who wants to be a full-time faculty automotive, we are hiring.
See, Mark, thank you for reminding me. Sorry about that.
Also, Skyline College is hiring a full-time faculty tenure track. The job posting reopened. We're looking for a undercar or brake suspension teacher. So that just came open. It's available, and we're looking to hire for the fall.
Great. Ruben, thank you. Ruben, if you could send me a quick write-up on that, I'll send that out in an email. I forgot to do that, Mark. I apologize again. So that we can kind of get this going and making sure that everybody in the region understands that there's opportunities out there in case they're interested.
Great.
Pam, you don't have to apologize to me.
I'm sorry, Mark. Sorry.
Okay.
I apologize.
We love you, Pam.
Sorry.
Have a good weekend, everybody.
You too,
Thank you,
Ruben.
everyone.
Thanks for coming, everybody.
Thanks, Kurt.
Good to see you guys.
You
Hey,
too.
Robbie, good to see you.
Okay,
Thanks,
good.
Pam.
Great to
Thanks,
see
Kurt.
everybody from Southern California and all the high school teachers. Thank you for joining us. Great to have you.
Thank you, Kurt and Pam. Appreciate you both.
Thanks a lot. Yeah, you need to hit stop recording.
Oh, it's true. We are now.
How do I
recording.
stop this thing?